Alright, hi, survival books, ebooks.com. Alright, your U.S. Army Light Wheel Vehicle Mechanic M. Moss 63B Skill Level 3 Course Wheel Vehicle Braking System Subcourse number 0D1 or OD1008 5 credit hours. General. The Wheel Vehicle Braking System Subcourse, part of the Light Wheel Vehicle Mechanic Moss 63B Skill Level 3 course, is designed to teach knowledge to develop skills surfacing, maintaining braking system information, provide with the principal operation, mechanical, hydraulic, air, electrical brake system information. Also provide with the inspection of these systems. Subcourse is presented in 3 lessons. Each lesson is corresponding terminal objective indicated below. Lesson 1 would be your fundamentals wheel vehicle braking system. Lesson 2, air hydraulic brake systems. Lesson 3, air brake systems. And then we'll continue to the title page, table of contents, introduction, wheel vehicle braking systems, fundamental wheel brake systems, learning event 1, describe the principal braking and braking systems. Learning 2, describe construction and operation of hydraulic brake system. Lesson 3, describe inspection procedure, hydraulic brake inspection, practice and answers. Lesson 2, air hydraulic brake systems. Learn 1, describe the components for the air hydraulic brake system. Learning 2, event 2, describe operation air hydraulic brake system. Learn 3, describe inspection procedure for the air hydraulic brake system. Alright, lesson 3, air brake system. Learning event 1, describe the components of straight air brake system. Learning event 2, describe operation straight air brake system. Learning event 3, describe inspection procedure straight air brake system. And then continuing page left intended blank. Alright, introduction to wheel vehicle brake system. Up to this point, each one of the subcourses has covered all of the things that would need to make the vehicle forward and backward. We know that the operator has controls to make the equipment faster, slow, right to left, through mud, snow, sand, on level the roads. What does the operator do if the child runs out in front of the moving vehicle with the traveling over the road point, reach of the bridge is washed out? The answer is that operator must have one or more controls will bring the vehicle to the stop rapidly with a small effort. This braking system provides controls. Braking is using a friction to slow the vehicle to bring it to a halt or hold it in stand position. Brake is a device that is secured with the vehicle axle housing, which do not rotate. We use slow down, hold wheels, which do rotate when the rotating parts of the rod with the contact down rotating parts. The friction caused by the rubbing creates braking action. All vehicles must be built so they may have the minimum braking requirements. For many years that has been set a standard that the braking system must be able to stop a vehicle traveling 20 miles per hour within 30 feet. We must remember, however, this does not mean the vehicle will always stop in 30 feet. It does not mean that the tires could get enough traction on the road. The brake must hold well enough to stop it in the distance. To get an idea how much power is involved in the braking system, imagine a 10,000-pound truck traveling 50 miles per hour being braked at a rate discussed above. The energy required for the braking would be equivalent to 500 horsepower. This is much more than the vehicle engine could even produce. Most of the braking system in passenger cars can handle 8 times the power delivered by the engine. This subcourse is caused and provided with the knowledge of how braking system components operate. Alright, lesson 1, fundamental wheel vehicle braking system. Describe the principal automotive brake system, the construction, operation, mechanical, hydraulic brake system conditions. Give the information, principal braking, construction, operation, internal, external drum brake, disc brakes, mechanical, hydraulic brakes, parking brakes. And then reference TM98000, learning investment 1. Describe the principal braking and braking system. Introduction. Braking action wheel vehicles due to the control force, hold, stop, the reduced speed of the vehicle. Many factors must be considered with the design braking system. For an automotive item, the vehicle weight, size of the tires, and type of the suspension are built with the influence of the design of the system. Power needed to brake a vehicle is equal to needed to make with a go. However, even safety reasons, the brake must be able to stop the car in very short distance. Example, the passenger car equipped with the 80 horsepower engine can normally accelerate from a standstill at 60 miles an hour in 36 seconds. On the other hand, the brakes must be able to decelerate the vehicle at 60 miles an hour to a stop within 4.5 seconds. You can therefore have a braking force is about 8 times greater than the power developed by the engine. Each part in the braking system must operate with a very positive action accomplished with a tremendous braking effort. The job of the wheeled vehicle mechanical is maintain the braking components in a state of repair that ensure that the surface will brake when needed for you to keep the brake system components working shape. You must understand how the system works. In this lesson, you will discuss principal operation components containing the various types of the braking system. Braking action, you use the control force to slow the speed of the stopping moving object. In this case of the vehicle, it is necessary to know the friction is to understand braking action. Friction is a resistance between moving the two surfaces of the object for the touching each other. Example of friction is the force of the drive the stop of your hand as you apply pressure slide and across the table of the desk. This means forcing the surface of the object that not move the stationary against a moving object surface. The resistance of the movement of the rubbing action between the two surfaces of the object is slowing down the moving surface. Automotive vehicles are braked in this manner. Figure 1 shows the development of friction and heat. Brakes on early motor vehicles, nothing more than modified wagon which brakes on horse-drawn wagons. These were hand-operated mechanical lever-type brakes forced with a piece of wood against one or more of the wheels. This causes the friction drag of the wheels or these. There's also friction between the wheels of the ground that tries to prevent the wheel from skidding on the ground. When the vehicle is moving, the third force presents. The force is known as kinetic energy, the name of the given force that tries to keep an object in motion in started movement. Or when brakes are applied with the wheel, either with a roller skid, depending on which is greater the friction between the braking surface between the wheel and the road. The maximum retardation slowing down is reached with the friction between the brake surface is just enough to allow to lock the wheel. At this time, the friction between the brake surface of the wheel and the road almost of the same. This is also the friction that can be used for the retarding slowing down of the motion of the vehicle. The amount of friction between the road and the vehicle is limited. Braking should the friction between the braking surface go beyond, the braking surface will lock and the wheels will skid. When the wheel rolls along on the road, there is no movement between the relative of the motion wheel and the road. At this point, but the wheel touches the road. This is because of the rules of the road of the surface of the when a wheel skids, it slides over the surface of the road, and this is relative of the motion between. Because of the wheel is not turning while the moving over the road, the wheel skids. Friction is reduced through decreasing the braking effort. However, the brakes are made so that the vehicle operator is able to lock the wheels if enough force to the brake lever pedal is applied. Figure 2 shows braking arrangements, horsepowers, and vehicle speeds. Height, horsepower of the engine, horsepower of the brakes. Most of the youth of us now increase the vehicle speed required for the increase of the power output of the engine, and is true for the increase for the speed required for the increase for the braking action necessary to bring a vehicle to stop. Brakes must only be able to stop the vehicle, but must be stopped within short distance as possible. The brakes are expected to decelerate, slow down a vehicle faster rate, engine accelerate. They must be able to control the greater power of the develop of the engine by the engine. For this reason, well-designed, powerful brakes have to be with the use of the control of the modern high-speed motor vehicle. For the time needed to stop the 1/8 of the time needed to accelerate from the standing of the start, but the brakes can handle 8 times the power developed by the engine. Are factors controlling retardation. The amount of retardation slowing down obtained by the braking system of the vehicle is affected by the several factors of the wheel brakes used for today's motor vehicle, but the factors are pressure exerted by the braking source, lining the drum of the wheel, weight carried on the wheel, over radius of the wheel, the distance from the center of the wheel to the outer tread of the tire, radius of the brake drum, and the amount of the friction between the braking surface, the amount of the friction brake between the tire and the road. The amount of the friction between the tire and the road determines the amount of the retardation that can be attained with the application of the brakes. This is things in effect for the amount of the friction between the tires of the road, amount of type of the tread in contact with the road, and surface the type of the condition road surface that will much less friction, thus much less retardation. Wet, icy roads and good dry roads. Total 3, through figure 3, total vehicle stopping distance. White is reaction time, shaded is applying brakes, and shows the feet in the miles per hour. Another factor of the affect for the distance required for the bringing the vehicle to the stop of the drive and the reaction time and the time required for the driver to move his or her foot from accelerator pedal to brake pedal, applying with the brakes while the driver is thinking of applying with the brakes, reacting to do so with the vehicle will move certain distance. How far it will depend on the speed after the brakes applied, but the vehicle will travel the additional distance before brought to a stop. The total stopping distance of the vehicle, the total distance covered by the during the driver, the reaction time of the distance during which the brakes are applied before the vehicle stop. The illustration shows at the top of the total stopping distance required as various vehicle speeds. This is assuming average reaction with 3/4 of a second, and the good brakes are applied under the most favorable road conditions. External contracting, expanding brakes. External contracting, internal expanding brakes. Show for the brake band, the brake lever, Foghorn brake shoe, drum, brake lining. External contracting cam to expand brake shoes, brake shoe, and anchor pins, and drum and brake lining. And internal expanding. There are several types of the braking systems. All systems require the U of the rotating of the returning of the rotating unit, non-rotating unit. Each of these units contain with the braking strip with the rub together. Give the braking action the rotating of the military wheel with vehicle braking. Consider the drum steer with the wheel. This non-rotating unit consider the brake shoe. The linkage needed to apply the shoe to the drum brakes are either external contracting and internal expanding type, depending on the on how the non-rotating brake surface is forced against the rotating braking surface. When a brake shoe with a brake band is applied with again for the outside of the rotating brake drum, the brake is done with the external contracting brake. On this type of the brake, the non-rotating braking surface must be forced inward again for the drum, producing the friction necessary for the braking. The brake band is tightened around the drum by moving the brake lever and left. The elaborate cover is provided with the external contracting braking ring exposed to the dirt and water. Other foreign material rapidly wears the lining of the drum. This is particularly true with wheel brakes. The non-rotating unit will be placed inside of the rotating drum with the drum acting over the cover of the braking. So for the type of the brake is known as the internal expanding brake because non-rotating brake surface is forced outward against the drum to produce the braking action. The type of the brake is used for the wheel brake for the cars and trucks because it permits more compatible economical construction. The brake shoe's brake operating mechanism may be mounted on a backing plate or brake shoe, which may be fitted with against and closed with the opening end of the brake drum. This protects the braking surface from the dust and other foreign matter. Alright, some of the vehicles fitted with the third type of the brake system known as the disc brake with the rotating member known as the rotor brake pad. The position each side of the rotor brake operate by squeezing them together, grasping the rotor, slowing and stopping the disc. Figure 5 shows the brake drum construction: aluminum steel, aluminum coil fin, and cast iron liner. Cooling ribs, steel, cast iron, and liner, steel braking surface. Brake drums usually being pressed to steel cast iron combination of two metals. Cast iron drum dissipated with the heat. Friction most rapidly with the steel drums. Have better friction surfaces. However, the cast iron drum is more strong. Is made stronger as it should be, and it will be much heavier than the steel drum. Alright, to provide lightweight with enough strength with some of the drums are made with the steel with the cast iron line with the brakings for the type of the drum with the central fuse brake drum. Cooling ribs are sometimes added with the outside of the drum to give more strength with a better heat with the dissipation. Brake surfaces of the drum may be grounded. They may be machined to smooth finish. For good braking action, the drum shall be perfectly round and have the uniform surface of the brake drums out of round for the pressure for the exert of the brake shoes bands of the heat produced by application of the brake drum surface becomes so gored, which is worn in braking action. The surface is badly scored and the drum is out of round. It is necessary to play with the drum and to regrind it or turn it down into the lathe until the drum is again smooth and true. Alright, figure 6 shows the brake and shoes and lining. No mild brake lining, woven brake lining, rivets, brake lining, brake shoes. Brake shoes are made out of moldable iron, cast steel, drop forged, pressed steel, and cast iron aluminum. Pressed steel is usually with you that becomes cheaper to produce with the larger quantity of steel shoes. Expand approximately the same rate with the drum, which is heat is produced with the brake application. There is maintaining clearance between brake drum, brake shoe under most conditions. Alright, a friction line riveted bonded to the shoe make with the contact with the inner strip of the brake drum with the brake with the supply with the rivet type lining with the brace rivet the brass rivet that usually used because brass is not unduly scored with the drum with the lining with the worn aluminum rivets are not very satisfactory because they corrode and very readily in salt water. Unbonded lining is not riveted. It is bonded directly with the shoe with a special cement. Different than brake design component conditions operating make it necessary various type of the brake lining. With the molded brake lining is made with the dense, hard, compact materials cut into block with the fit different sizes of the brake shoe. Friction qualities are low because of the smooth surface dissipated, but rapidly wears longer in the woven type. The woven brake rivet lining is made with asbestos fiber, cotton fiber, copper, or bronze wire. After being woven, the lining is treated with the compounds intended to lessen the effects of oil and water if they should come in contact with the lining. However, the oil particularly will reduce the friction quality of the lining even after treatment. The lining is compressed with the heat treated before being installed. The main advantage of the woven lining is its friction qualities. However, it does not dissipate heat as rapidly, whereas molded brake lining is the type of the lining that is generally not used in automotive vehicles. Alright, rotating, non-rotating unit. The brake drum and the mount directly onto the wheel provide the rotating brake for the brake sheet, sometimes known as brake plate and the dust shield, mounted on some fixed structure, such as the axle housing the brake shield forms the support from the non-rotating brake shoes as operating mechanism. Brake shoes may be anchored to brake shield without a separating pin with the same pin with the spring clips usually to hold the shoes and close the brake shield to prevent them from rattling. A fairly strong retraction spring is hooked between the shoes to pull them away with the drum of the brakes and release when the mechanical hook pressure can be applied with the brake shoes by means of the cam toggle double lever arrangement cam turned by a small lever. This method is frequently used. Turning the cam by lever tends to spread the brake shoe push to the outward against the drum, and the hydraulic system pressure is applied to the brake shoe by means of cylinder and piston. 7. Self-energizing servo action servo the cam applying force for drum rotation, shoes, and anchor pin drums. Alright, and then it shows the drum rotating, primary applying force and secondary heel and a heel adjusting screw drum rotation, car moving release adjusting screw. Alright, your brake operating linkage alone does not provide enough mechanical advantage for the good braking with some way with increase of the pressure for the brake shoes needed. Self-energizing action can be used to do this. Selling the shoes is the start of the movement of the linkage. There are several variations. Self-energizing action always done by the shoes themselves with the 10 with the turn with the turning of the drum of the brake shoes anchored with the drum turn with the direction with the shoe with the 10 with the turn the drum when it is forward against the drum. The friction is trying to cover the shoe with the turn with the drum with the happens with the shoes push with against with the anchor pin since the pin is fixed to the brake shield with the pressure 10 with the wedge of the shoe with the turn of the pin and the drum of the cam should increase with the pressure with the shoe with the wet action increases the shoe is forced still more tightly against with the drum increase with the friction. Self-energizing action result with the more braking action that could be attained by the pressure for the cam against the shoe alone with the braking must also use the principle increase with the pressure for the braking so for the known self-energizing brakes. It is very important that the operator control the total braking action at all times, which means that self-energizing action should increase only upon the application more pressure on the brake pedal. The amount of the self-energizing action available that depends on the mainly location with another anchor pin. After the pins are moved down, move toward the center of the drum of the wet action, increase until the point is reached for the shoe will automatically lock. The pin must be located outside of the pin point so the operator can control the braking. Two shoes are anchored with the bottom of the brake shield itself. The energizing action is effective only on one shoe, with the other shoe with the tends to turn away from its pivot that reduces the braking action. The wheel is turning in the opposite direction. Self-energizing action produces on the opposite shoe. Alright, two shoes can be mounted with the self-energizing action effective with them both with the dome with the pivoting of the shoe with each other, the relieving the pivot, the free with the brake shoe, with the only physical effort required for the operating first and primary shoe with the shoe, then apply with the more pressure brake surface without increase with the pressure for the brake pedal, with the anchor pin fitted in the slots, the free end with the brake shoe with the med with the anchoring, allow with the shoe with the move with the expand with the against the drum with the brakes with the apply with the self-action energizing action with the brake shoe with the transmit from the pivot with the secondary shoe with the brakes will then tend to turn with the drum with the will be wedged against the drum by one anchor pin, and the other anchor pin will be caught with a similar action when the wheel is turning with the opposite direction. Another type of the brake shoe with when you can consider the two links of the anchor together the brake shoe with the end of the link, each link with a pivoted one of the brake shoes. This allows more even application of the brake surface because of the freedom of the movement for the brake shoes. Each shoe is self-energizing in the opposite direction. Figure H of the disc brake assembly, the brake pin, lining pad, the brake shoe, the inner caliper housing, splash shield, ventilating louvers, typical drill disc brake, nut lock, cotter pin, bearing, nut hub, outer caliper housing, braking disc. The disc brake, like with the drum brake assembly, is operated with a pressurized hydraulic fluid. With the fluid is rotated around the caliper steel line with a flexible high-pressure hose. Develops its pressure for the master cylinder, one for the brake pedal with the depressed fluid, and for the caliper begin to force the pistons for outward with the outward movement. The force of the brake begin with the moving motor. Once at the point of the reach of the braking action, begin with the grade with the fluid pressure exerted with the piston from the master cylinder with the tire with the brake pads will be forced again for the rotor. Increase with the pressure also will cover the increase of the braking effort as the pedal is relieved. The pressure with the diminishes and force with the brake pad is reduced. Allow for the rotor to turn more easily. Some calipers allow for the brake pad to rub lightly with again for the rotor at all times. Relief the position of the design using rolling action for the piston seal for the maintain a clearance approximately at 0.005 of an inch when the brakes are released. Both disc and the drum brake drum assemblies on the U of the monitor area area, well designated, sufficiently exhaustive, exhibit a certain inherent advantage and disadvantage. Most important parts of the interest discussed below. One major factor that must be discussed with the automotive brakes as well with the other brake systems is the system ability to dissipate heat. Discussed previously with the hydraulic byproduct with the friction with the heat, with the because of the most braking system, with the concept of the developing braking force. It's highly desirable for the braking system to dissipate heat rapidly and efficiently as possible. The disc brake with assembly become with the open disc with the ability to dissipate with the half heat faster than the brake drum, with the feature become with the disc brake assembly with less prone for the brake fade with the due for the building up the excessive heat. The disc assembly also may have additional heat with the transfer quality due to the use of the ventilating rotor. The type of the rotor may built in the air passes between the friction surface to aid the cooling. With the brake drum and assembly required with the initial suit to drum, the clearing of the adjusting of the periodic check the disc brake assembly with the self-adjusting maintained with the proper adjustment at all times. With the disc assembly automatically compensates the lining wear with allowing piston caliper to move outward, thereby taking excess clearance between the pads and rotor. The disc system is fairly simplistic with a comparison to the drum system due to the design of the lack of the moving parts and spring of the disc assembly is likely to malfunction. Overhauling with the disc brake assembly is faster because of the simplistic design. It is also safer to do with the fact that the disc brake assembly is open and asbestos dust linings is less apt to be caught in the brake assembly. They like brake drums and rotors to be a machine with excessive the scoring and is present the rotors are stamped with a minimum thickness dimension which should be not exceeded. The drum brake assembly repair required for the drum to remove the lining and inspection, while some of the dust brake pads have built-in lining wearing indicator produces an audible high-pitched squeal when the linings are worn excessively. But this high squeal with the result of the linings wearing at a point allowing the metal indicator to rub against the rotor of the wheel turns because of the small friction area with the lack of the self-energizing servo effect of the disc brake assembly requires the use of auxiliary power booster to develop enough hydraulic pressure for the satisfactory braking. Alright, a floating caliper. The floating caliper is designed to move laterally and is mounted with the movement to allow the caliper to maintain with the center position with respect with the rotor. With the design also permits the braking force applied with the equality to both sides of the rotor. With the floating caliper, usually one piece with a solid construction, with a single position piston to develop the braking force. The type of the caliper operates by with pressure hydraulic fluid. Like all hydraulic calipers, the fluid under pressure first enters with the piston cavity, begins with the force of the piston outward. That happens with the brake pad meets with the rotor with additional pressure with the forces. A caliper is assembled to move in the opposite of the direction of the piston, thereby forcing the brake of the pad outside of the vehicle with the piston engaging the rotor. As the pressure is built up behind the piston, it is then forced with the brake pads to lie tighter against the rotor to develop additional braking force. The fixed caliper. The fixed caliper is mounted originally with a spin with a splash shield with a design with a caliper, usually with a made with a two piece of the heavy for the 2 or 3 or 4 piston in use. Piston, which may be made of cast iron, aluminum, plastic, is provided with a shield with a dust boost and it fits snugly with the bores of the machine in the caliper. The interaction of the fixed caliper accomplished within this piston and with the move of their bores. Lining should be worn evenly with the one side of the caliper. Excess clearance will be taken by the piston simply but on moving further within its bore. The edge of the brake is applied with the fluid pressure ends of the caliper on one side as in routed other through internal passageway. The external with the tube connect with the open half opposite half of the caliper as the pressure is increased. The piston force of the brake pad against the rotors evenly through the maintain equal amount of the pressure both sides of the rotor. As discussed above, the fixed caliper and the multi-position design provided with the braking force. The fixed caliper has been designed to use with the 2 and 3 and 4 piston. With the dual piston design provides a slightly marginal safety over single piston floating caliper. In the event of the piston seizing with the caliper, the single piston caliper will render useless, and the dual piston design would still have the one working position restored with the braking ability. With the 3 or 4 position design provided with the use of the large brake, allowing the brake force developed with the now spread over the large area with the brake pad. Alright, mechanical braking system. On wheel vehicle with the energy supply with the operator's foot with the push down with the brake pedal, the transfer for the brake mechanism for the wheel with the various means with the mechanical hookup was used. First motor vehicle with the mechanically operated braking systems are practically obsolete, but however the mechanical hookup still used for the part of the braking system in many vehicles. Parking brake. Auxiliary brake is generally used with the lock with the rear wheels and properly propel the propeller shaft of the vehicle to prevent the vehicle from rolling when it's parked. It can be used to stop the vehicle in an emergency if the surface brakes fail for the reason of the brake parking brake, sometimes referred to as the emergency brake. Figure 9 shows the external contracting brake of the brake band, the control over the linkage of the brake drum. The M151 series with the truck with the external contracting tab of the brake with the bottom with the transmission transfer of the brake drum that is behind. Bolted transfer output shaft of the flexible brake band with the internal lining located around the outer circle of the drum of the brake. Is made with a self-energizing gear, the forward, backward, the move of the vehicle with the region of the brake band is anchored with the point with the just opposite of the point of the operating force is applied. One half of the band with a wrapper tighter with the self-energizing on the drum of the one direction, one half of the opposite of the direction. Mechanism of operating of the brake is usually simple with the belt crank arrangement. Controlled by hand lever applying with the brake lock with the transmission transfer output shaft with the which end the turn lock with the propeller shaft holding the wheels and then through the axle assembly. When the hand lever is relieved, the release position of the brake band is relieved with the spring pressure. The parking brake system of the M88 or the M1008 series of the vehicles used with the rear vehicle brake drums to hold the vehicle in motionless. One of the operative of the vehicle applied with the parking brake with the effort which with the brake lever is moved, the transmit with the rear of the shoes or cable by cables levered in simple system must be applied with the physical effort of the operated force to the rear brake shoe into tight contact with the drums. Parking brake system, the M998 series vehicle, dismount with the rear differential propeller shaft with the head vehicle for the motionless operator of the vehicle, applied with the parking brake with a mechanical linkage, multiplied with the force of the operated transmit, increase pressure of the brake unit with the brake unit with the use of the force to push with the brake pads again for the drum. Some of the large truck with the parking brake have the drum internal expanding brake shoe with some of the shoes to service brakes. Brake action is attained by the clamping the rotating drum through the two brake shoe with the blinding of the brake shoe, the contact with the friction surface of the drum. The 2.5 by 5-ton military trucks have the parking brake that operates with the clamping of the flange with the drum with the brake between the brake shoes. Although this construction is somewhat different, they use the same operating principle with the disc brake. Brake is mounted with the rear of the transfer lock with the wheel through the brake assembly with the propeller shaft with the drum and the flange with the both inner and outer braking strip of the brake shoe with the line located on the inside of the with the outside of the drum. The outer brake shoe is in support with the pivot of the anchor and its lower end. The inner brake shoe with the support with the brake shoe left with the pin tube with the center of the bolt of the outer inner breaker shoe with pulling the brake shoe left with the move of the brake shoes together with the clamping of the drum flange between them. Alright, learning event number 2, the describe the construction operation hydraulic brake system. Hydraulic brake system, wheel cylinders, brake pedal linkage of the master cylinder piston, master cylinder, wheel cylinder pistons. In hydraulic braking system, the pressure applied with the brake pedal with the train with the brake pack mechanism, the liquid, since the liquid cannot be compressed with the ordinary pressure forces of the train, but is solidly just as the rods were used for exerted at any point upon with the confined liquid distributed equally with the liquid in all directions, that all brakes are applied equally. In the hydraulic brake system, the force is applied into the position with the master system of the brake pedal with the operator of the piston by linkage E of the brake of the provide with the cylinder inside of the cylinder with the opposite opposed with the neck of the brake shoe. When the brake pedal is pushed down, the linkage move with the piston within the master cylinder, forcing the brake liquid and fluid into the cylinder. Master cylinder with the fluid travel with the tubing and flexible over the four-wheel cylinder. The brake fluid enters the wheel cylinder between the opposed with the position pressure for the brake fluid with the piston cover to move out the force of the braking shoe outward again for the brake drum with the pressure for the pedal increase for the more hydraulic pressure for the build over the wheel cylinder more forward exerted against the end of the brake shoes. When the pressure of the pedal is relieved, the retracting return spring for the brake shoe for the pulls of the shoes away from the drum. This force of a wheel can cylinder piston to release the position also forward of the brake and fluid back of the flexible hose tubing of the master cylinder. Figure 11 shows the master cylinder. The fluid is in gray. The intact port with the filler cap, bypass port, supply tank valve seat, and check valve with the return spring, primary cup, piston, and secondary cup, linkage, and boot. And that's your master cylinder. The master cylinder housing is an iron casting contained with the cylinder, large reservoir of brake fluid with the reservoir with the carrier with the reservoir fluid, and enough proper operation of the brake system that is filled with through a hole with the top of the which with the seal with the removal of the filler cap with the contained with the vent with the cylinder is connected with the reserve with the two drill with the hole with the port large intake and then port and small bypass port. Master cylinder piston long spool like member with the rubber with the secondary cup seal with the outer end with the rubber primary cup with which the acts again with the primary braking liquid just ahead of the inner end. The primary cup keep it against for the end of the position return spring with the inner position has several smaller bleeding ports for the path through the edge of the base of the rubber primary cup. Seal stop of the disc out, then the outer end of the cylinder retaining spring with a snap ring with the piston stop of the rubber boot covers of the piston end of the master cylinder prevent the dust other foreign material entering the cylinder. This boot with preventing air from being compressed within it. Alright, an outlet over the end of the cylinder with the combination for the inlet outlet valve with the help of the plate with the position return spring with the check valve is a little different for the most check valve with the wheel that with the let the fluid pass through them direction option only. If enough pressure is applied through the valve, the fluid goes either through the around it in either direction. That means for the sum of the pressure for the brake line with the check valve with the tip of the rubber valve cap at the inside, the steel valve case with the seat with the rubber valve, the seat with the fits for the end of the cylinder, the sum of the design check valve with the tip of the spring operated outlet, the seat with the valve cage rather than rubber cup outlet valve with the principal operation is the same with the piston with the return spring normally hold with the valve cage again with the rubber valve with the seat with the seal, the brake fluid and brake line. Figure 12 shows the wheel, cylinder, blade, screw, and cylinder housing, your boots, and your piston, and your cup, and your returning spring. The wheel cylinder changes with the hydraulic pressure for the mechanical force of the push of the braking in, with the drum of the wheel cylinder, with the housing of the mount, with the brake backing plate with this inside of the cylinder with the two piston move in the opposite direction, the hydraulic pressure with the which at the same time pushing the shoe against the drum, piston and piston stems connected with directly to the shoe with the rubber piston cups fits in. Cylinder bore again for each of the piston to prevent escape of the brake liquid. There is little between the cups to keep them in the position against the pistons at the open end of the cylinder are fitted with the rubber to keep the foreign matter out. Brake fluid enters the cylinder with the brake line connection between the piston and the top of the cylinder between the piston is a bleeder hole screw with which the air is relieved for the system and the being filled with the brake fluid. 1. Some of the vehicles stop wheel cylinders U with the compensate with the faster rate of wear with the front shoe within the rear shoe with this happen to be killed with the self-energizing action U with the larger piston with the rear shoe receive with more pressure for the offset with the self-energizing action with the front shoe. If desired, bolts of fuse independently self-energizing necessary with a 2-wheel cylinder, one for each shoe with each of the cylinder a single piston with the mount with the opposite side of the brake backing plate with the other cylinder. So far, we'll discover the parts needed for the make of the hydraulic braking system that happens with these parts, but the brake will they apply with the release. Let's assume the master cylinder is installed with the vehicle, but the hydraulic system is filled with the fluid, and the driver pushes down with the brake pedal linkage move with the piston, and this is the master cylinder. The piston moves inward with the primary cup seal with the bypass port, sometimes known as the compensating port, by the bypass port closed with the piston, tramp of the fluid, or head with the crease of the pressure from the cylinder. The pressure forces the check with the valve with the open fluid pass with the brake line. As the pistons continue to move the flow of the fluid through the lines into the wheel with the cylinder with the hydraulic pressure cover the wheel cylinder with the piston move outward with the brake shoe with the gain of the brake drum. As long as the pressure is kept with the brake pedal, the shoe will remain pressed again with the drum. When brake pedal is relieved, the pressure linked with the push rod with the move of the master cylinder pressed in with the return spring pressure for the piston back to the release position, reducing the pressure it is in front of the piston with the check valve that slows down the circuit and return over the fluid with the wheel cylinders of the piston move the door with the release position of the cylinder and fluid with the master cylinder. Supply tank flows from the intake port, then through the bleeder holes in the head of the piston. Fluid will bend with the lips of the primary cup away from the cylinder wall, and the fluid will flow with the cylinder ahead of the piston. When the pressure drops in the master cylinder of the brake shoe, return with the spring pulls of the shoe away from the drum of the shoe that is pulled away from the drum screw to the wheel cylinder piston together with the force of the brake fluid to flow back of the master cylinder. Or the return check fluid force of the check valve with the clove of the entire check valve with the force off the sheet, but the fluid flows in to the master cylinder out of the edge of the valve with the piston with the master cylinder with the return release position again with the stop plate with the primary cup of cover the bypass port. Any excess fluid from the bypass port with the reservoir with the prevent the package for locking up with the heat of the brake causes the brake fluid to expand. When the piston returns spring pressure again, it is more than pressure for the retaining fluid. The check of the valve, see with the valve will keep the slightly pressured brake lines, wheel cylinder, and brake system in next and now in position with the next brake application. Alright, learning event 3. Describe inspection procedure for the hydraulic brake system. The introduction of hydraulic braking system for the minor high speed of the automobile with the be kept in the high state of the repair. Not too many years of small with the defect with the braking system did not bother too much. In fact, but it might even not have even been noticed. Today, however, improved road conditions, higher vehicle speed with the bus for the more sensitive the steering the suspension system with the cover with the poor braking action to be noticed immediately. Braking system parts must be able to stand under the high pressure for the temperature and still be able to work properly with the vehicle to be operated safely. To properly repair the brake system, and is always the top condition. The mechanicals must be well trained with the desire of the best job possible. Before road test, inspect the condition. Hydraulic shift of the brake of the vehicle can be determined with the inspection following any items: fluid level in the master cylinder and the brake pedal free for travel. The brake pedal travel the free feel of the brake pedal hard, spongy. The leaks of the hydraulic system. Those determining operation performance amount with the wear of the brake parts. With the wear normally determined with the checking of one vehicle, one wheel to the of each axle. Inspect the fluid level of the master cylinder. First, clean away with the dirt with the fall of the master cylinder reservoir. Remove the filler cap to ensure the fluid level is level. Recommended to maintain the maintenance of the manuals pertaining to the vehicle be served with the level of fluid is determined by measuring the distance from the top of the filler hole to the level of fluid with the reservoir. If the fluid level is low, refer to the vehicle's lubrication order recommended the type of the brake fluid. If the fluid is needed, since the 1982 all military vehicles silicone brake fluid. Silicone fluid does not absorb water. It provides good corrosion protection. Good lubrication quality. Fluid is also compatible with the rubber components of the braking system. Check the master cylinder supply tank with the reservoir vents to make sure that there is not plugged with one small vehicle. On some vehicles, small holes drilled within the filler cap of the vent for the supply tank. Other vehicles, the supply with the tank is vented through lines fitting connected with the top of the master cylinder supply tank. Plunge vent can easily be cleared with compressed air. Measure for the brake pedal free of the travel compared with the measurement of the specification given the vehicle maintenance manual. The brake pedal free travel amount with the brake pedal with the move without moving the master cylinder pressure piston from the pedal with too much of the free travel will have the push to the further before the brakes apply. This is not enough free travel to prevent the brakes from releasing. Check with the total travel with the brake pedal with the push of the brake pedal with the down as fast as you can. You should not be able to push the brake of the pedal. The most of the trucks any closer to the floorboard than 2 inches. If there's about too much pedal trouble, the pedal feels free from the probably cover the normal wear of the brake lining with the lining is worn too badly. Adjusting the brake shoe with the correct with the excessive pedal traveling. Unfortunately, only way to determine the exact amount of the brake lining of the wear must fit the vehicle with the remove of the wheel of the brake drum. If the pedal travel is too great, the pedal feels spongy. There is likely a problem in air supply with the hydraulic system. Air trapped in the hydraulic system can be compressed and does not permit the brake supply with the pedal with the solidly with the brakes, and the methods for the correcting of these problems are covered later in this lesson. Inspection hydraulic system with the leaks of the large leaks with the detect with the checking of the pedal travel with the dome with the holding of the steadily with the pressure brake pedal with the few minutes. If the pedal with the continue with the move down, there's a large leak. Small leak cannot be with detect with it as well, but they cover the pedal with the fall away from the slowly notice. Look the entire hydraulic system over the invisible indication of leakage. Inspect with the master cylinder, especially around with the rubber boot with the external fluid leaks. Inspect all steel line with the tubes for the leakage and loose fitting of the wear with the dents and corrosion with the end missing with the retained clip. Inspect flexible hose for leakage cuts and the cracks. Situation for the evidence for the rubbing and for the other parts. Inspect with the area with the lower edge of the backing plate with the presence of the brake fluid or grease. The leakage either of the brake fluid or grease or at the wheels indicate brake problem. Road test inspection. Road test the vehicle. Check for the operation of the brakes. The stopping several times with the traveling a smooth road. Check for the squeaking, the grinding sound when the brakes are applied. This the amount of pressure required with the brake pedal at the top of the vehicle. With the vehicle pulling on one side of the brakes are applied with the uneven. If the brakes are squeaking, grinding sound, some of the more common cause of the glaze with the worn and lining with the low and loose of the brake shoes, dirt embedded in the lining, improper adjustment, brake fluid or grease on the lining, the second cord, brake drums. The wheel of the brake drum will have to remove the noisy brake of the brake parts of the inspect will determine the exact cause of the noise. When excessive pressure must be applied with the brake pedal to stop the vehicle with one or more following items of the may cause glaze, worn, broke lining, improper adjusting, brake shoes, dirt braking the brake drums, grease and brake fluid in the linings faulty, master cylinder with the binding pedal linkage restricted brake line. After road test inspection, and such things the pulling on the one side of the board, braking action for the note during the road test after the road test inspection is done. Many faults occur with the brake system that can cover the vehicle with the pole with one side, however, all the faults with the one thing with the common effect of the brake of the one wheel causing the wheel to hold either more or less than the other vehicle with the wheels. If effective to hold more of the vehicle pulls forward the affected wheel. If the hold less than the vehicle pulls away from the affected wheel, the most common fault of the cause of the brake hold the uneven or unequal brake adjustment with the grease and the brake fluid with the lining, dirt in the brake drum with the brake drum. Brake drum of the rotor score with the rod with the different kinds of the brake lining with the opposite wheel of the primary, secondary brake shoe with the and reverse one wheel on some vehicle with the glaze or worn lining of the restricted brake lining with the wear with the weak brake shoe with the return spring, sticking pistons wheel with the caliper cylinder. If the inspection indicates the wheel brake is fault, you must determine the condition brake part of the wheel brakes and by removing the one over the wheel brake drum with each of the axles. Some of the inspection brake parts on these wheels, if reasonable to assume the condition of the both brake assembly on the one axle will be able to same and inspect the condition of the brake drum, brake lining, brake shoes, anchor, hold down springs, retraction, and return springs, brake shoes, adjusting mechanism, wheel, cylinder. or this page is intentionally left blank. Then you have your practice exercise and your answers. Moving on to lesson 2, air hydraulic brake systems.